Hello everyone, I'm Tanya Dubey, pursuing MTech from IAPS DABB. This video presentation is on topic Clouds are Distributed System, which is mentored by Dr. Vivek Srivastava Sir. In this system, cloud computing, we have heard the term cloud distributed system a lot. So what is relation between clouds and distributed system? So in this presentation, I'm going to talk about how cloud is in fact a distributed system. So a cloud consists of hundreds of thousands of machines on a data center side collected in an integrated center. This we call as a server side. On a client side, there might be thousands to millions, maybe even more machines which are accessing services that are hosted by these servers. Maybe web pages, maybe websites, maybe objects that are being stored, and maybe varieties of different services. So that's on the client side. On a server or on the data center side, the servers communicate amongst one another. So there's constant communication going on there. The client, of course, directly communicates with the servers. Each client can communicate with one or more servers. For instance, every time you access your Facebook profile, your client process, whichever browser you're running your Facebook client on, is going to access multiple Facebook servers. Some for the photos, some for the profile, some for the wall, and so on and so forth. The client, of course, communicate with each other. This is, of course, that happens in a cloud as well. Now, all this communication that I described mean that cloud is in fact a distributed system. The fact that servers communicate amongst one another means that is a distributed system consisting of many different servers sending and receiving messages amongst one another. This we call as a cluster. A cluster is a collection of machines that are communicating one another over a network. The clients communicating with the server also makes it a distributed system, very large scale distributed system. The client communicating with one another, for instance in a peer-to-peer system like BitTorrent, also means that it is a very large scale distributed system. So all these different aspects that I have described for cloud are also aspects of distributed system. Therefore, all these distinguishing features of the cloud are in fact features of the distributed system as well. The fact that we have many servers in a cloud on a massive scale means that is a distributed system. The fact that we can access multiple servers anywhere, the on-demand nature of the cloud, means again that's a feature of the distributed system as well. And that means the cloud are special class of distributed system. The data and its nature. When we have lots of data, we need to cluster many different machines to store the data. And again, the programming paradigms that exist today like Hadoop and MapReduce, the NoSQL storage systems, all of these require clusters. So all of these require many different machines communicating with each other. So, as we discussed, that cloud is a special kind of distributed system. In fact, cloud is our latest nickname for a distributed system. Previous nicknames or other names that we might have familiar with might include peer-to-peer systems, grids, clusters, and time-shared computers in the data processing industry. All of these are distributed systems. So every one of these is a special kind or special class of distributed system. And so is a cloud. A cloud is no exception. So nicknames comes and go, and different kinds or classes of distributed system come and go, but the core concepts that underlie the distributed system stay the same. And these core concepts continue to be used decade after decade. One example is Lamport timestamp. If you have heard of it, it was invented way back in the 1970s and 80s, but they are still continue to be used today in almost all the cloud and distributed systems that are implemented today. They are example, and that's why it's important us to know, and we should know the basic core concepts that underlie the distributed system. Also, a few years from now, there may be a new nickname, a new generation of the distributed system. However, the core concepts will likely remain the same, and they will continue to be used in real system. And that's why it's important us to know. So now we'll focus on to define the term distributed system. Moving ahead, we'll see various definitions of the term distributed system. But before that, let's take a step back and define a different but related term, that is an operating system. What is an operating system? Well, we have used a machine on devices, whether it's tablet or smartphone or laptop or computer or server. All of these devices, each of these devices runs on an operating system. If we have used a computer, we have definitely used an operating system. Before defining the term operating system, let's name some example of operating system like Linux, Mac OS, and Windows. And for smaller devices, we have Android and iOS, and there's also one named as Tiny OS. Now let's try to define the term operating system, but before we jump to some well-known definition, let's try to summarize what we know about operating system. The operating system, it provides a user interface to hardware. A computer, any device, consists of multiple devices like keyboard, mouse, monitor, hard drive, and of course CPU, memory, and many other peripheral devices are attached to it. All of these hardware pieces needs to be managed, and they are managed by software known as operating system. The operating system runs a special piece of code for each of these devices that is attached to it, and this piece of code is called a device driver. So as a user, we don't need to interact directly with these devices. It's very rare that as a user, we think I'm clicking the mouse and now I need to worry about the message that is being sent from the mouse to the CPU. But all of that is taken care by the operating system. The operating system also provides abstraction. For example, if we store a piece of code, we are really thinking of how does this code get stored as blocks on the disk. We are thinking of files. We are thinking of dictionaries or folders. When we run a code, we are thinking of programs being initiated as a process. We're not thinking of where does this run on the CPU or where does this is stored on the memory. Those abstractions are provided by operating system. So the operating system abstracts away the hardware specific features and provides to users features that are understandable and usable by the users. It has to manage different resources that is responsible for which process run when on the computer, which files get accessed on the hard drive, and so on and so forth. And of course, operating system is also a means of communication, whether it's sending or receiving email, whether it's accessing the web or just communicating in a distributed system. Here is the definition of operating system from Free Online Dictionary of Computing, also known as AllDoc. It defines an operating system as low-level software which handles the interface to peripheral devices, schedules tasks, allocates storage, and presents a default interface to the user when no application program is running. And so for instance, when we start up our machine and there's nothing running on it, the operating system is still running on it, and so it's going to occupy the CPU. I won't go through the rest of this definition. You can read it either by pausing the video or here or going to the AllDoc page online. But essentially, this definition seems to capture the characteristics that we said were true of operating system in the previous slide. Let's try to repeat the same for distributed system. Some examples of distributed system are single client machine communicating with the server. For example, NFS, also known as networked file system. Here, single client may communicate with a single server, and that's our distributed system. BitTorrent, where a BitTorrent is a peer-to-peer overlay which consists of millions of clients communicating with each other, is again another example of distributed system. The internet, where we have many servers and clients and routers, switches communicating with each other, is another example of distributed system. And the web, where we have servers and clients communicating amongst one another and each other, is example of distributed system as well. Hadoop, we have heard of it, and data centers are all examples of distributed system. So let's go back to Foldoc for its definition of distributed system. It says that distributed system is a collection of automata. Automata means programs whose distribution is transparent to the user. So the system appears as one local machine. It's saying that the collection of machine appears as one machine rather as multiple machines to the user who is using the distributed system. But this is in contrast to the network, where the user is aware that there are several machines and their location, storage replication, load balancing, and functionality is not transparent. Distributed system usually use some kind of client-server organization. So this is a follow-up definition for distributed system, but we have few problems here. The first problem is that the definition says that in a distributed system, a collection of machines appears as one local machine. But if this is true, then web is not a distributed system, because on the web, it is often the case that website A may be up while a different website B is down, and at a different point of time, website B is up and website A is down. And it's never the case that both A and B are up and both A and B are down. So these two web servers do not appear as one local machine, yet the web is a distributed system. The second mistake or problem we have is, it says distributed system usually use some kind of client-server organization. But this is not always true. In peer-to-peer systems like BitTorrent and many other peer-to-peer systems before it largely rely on client communicating with each other, and that's why they are called peer-to-peer systems. They do not rely on server except for some very minor functionalities. Essentially, without the server, these systems would continue functioning just as normally. Therefore, let's look at a couple of textbook definitions. Andrew Tannenbaum, in his textbook on distributed system, defines it as collection of independent computer that appears to the user of the system as a single computer. Again, the same issue. Michael Schlosser, another famous distributed system researcher, defines a distributed system as several computers doing something together. Thus, a distributed system has three primary characteristics: multiple computers, interactions, and shared state. But here it doesn't talk about servers or clients failing. So yes, it's a little bit worrisome. But we want to understand the insights of distributed system and study what algorithms run there. How are distributed systems designed, and how we can implement a distributed system, how distributed systems are maintained, and of course what are the real characteristics of distributed system. While searching for various definitions of distributed system and reading various definitions, I came across this working definition. It says that distributed system is a collection of entities, each of these entities being autonomous, programmable, asynchronous, and failure prone. And these entities communicate through an unreliable communication medium. So let me through this definition and explain each of these objectives here. The entities are essentially process. So each entity is a process that is running on some device. Each entity is autonomous. Autonomous means it's standalone, that is left to its own. It will run just fine. The entities are programmable. Of course, we have written code that is running underneath and inside these processes, and so of course they are programmable. And asynchronous, it is very important here. It means that each process or each entity runs according to its own clock, and these clocks are different. Entities or processes are not synchronized with each other. They are not always showing the same time as each other. So each entity may crash arbitrarily at any point. So they are failure prone. At any color for at any time or at some point of time, these entities are communicating through an unreliable communication medium. So they send and receive messages through each other. However, these messages are being sent may be dropped completely, or they may be delayed for inordinately long periods of time. That's the definition, the working definition that we have for distributed system. When we say entity, it means a process on a device. Would it be a small PC, or be it be a PC or a laptop, or some small sensor mode, and a communication medium may be wired network or wireless network or some combination. Again, programmable objective eliminates human interacting with each other, and asynchronous objectives distinguishes distributed system from parallel system. Parallel systems include multiprocessor system and supercomputers. But a very large number of processors share the same motherboard. They communicate with each other over a tightly covered network, and they have the same synchronized clock. So all the processors are showing the same clock at all the point of time. The distributed system is very different from that. A distributed system has it is asynchronous, and it means that clocks are asynchronized, and that's why distributed systems are harder to design algorithms and for implement for. As discussed, a process is an important entity in our distributed system. In fact, a distributed system, as we said, consists of many processes. In this example, I have three processes, P1, P2, P3, but there might be thousands of processes involved in a distributed system. We have unreliable communication network involved underneath. We are not interested in the insides of network, so I'll be leaving that. But we are able to send and receive messages via the network. So P1 might be able to send our message to P3, which then gets delivered at some point of time to P3, and that receives the message. So this is what we see as a distributed system. Multiple processes communicating by sending and receiving messages from each other. When we think of distributed system for working purposes, of course, that's what we need to think about, processes sending and receiving messages amongst one another. Thank you. That is the end of this presentation. Feel free to drop your doubts in the comment section.